Hi students, let us now solve question number 4. To solve question number 4, it is better to learn a new technique today, and which I call, or which is generally called the phasor technique. Phasor technique, okay, to add 2 or more waves. Okay, basically when I say add 2 or more waves, I mean the displacement of the waves. Displacement of waves. So here we know that any simple harmonic motion is a sine omega t. Yes or no? So this is called the amplitude, and this argument of sine is called the phase. This is called amplitude. So now there is a way to represent this function which is periodic. Okay, we can represent such periodic or alternating functions by an arrow like we used to do in vectors. Okay, that doesn't mean that this is vector. Okay, what I'm trying to say is any alternating function, it could be y equal to a sine omega t. In second PU you will learn about alternating current, where this will be current, this will be the amplitude of current, this will be the angular frequency of current. So any alternating quantity can be represented in such a way, diagrammatically it can be represented in such a way that you draw an arrow and the length of the arrow will not give you the magnitude of this vector because it is not a vector. Instead it gives you the amplitude of this function, and the angle it makes with any reference line you choose, that gives you the phase which is omega t. Okay, so an alternating quantity can be represented by a diagram schematically, and this quantity, you see what will happen in with time. In time this phase will keep increasing because this t will increase. Amplitude is constant because we are not considering damping oscillation. So after some time this error will come here, and then this error will come here, then this arrow will come in, but this angle keeps increasing. So basically this will revolve in a circular path. So that's why phasors are also called in literature as rotating vectors, though it is not actually a vector. Okay. So why this technique is, suppose you want to add two simple harmonic motion. Okay, so there is a particle, one wave is coming from one side, another wave is coming, and it is oscillating. So when both the waves superimpose and you want to find the resultant displacement, if you use trigonometry, it will be difficult. You have to remember trigonometric identities like sine A plus sine B, and the amplitudes are different. Suppose one is A1 sine omega t, other one is A2 sine omega t. Then though you cannot take even A common. So then it won't be sine A plus sine B formula also. On top of that, if I give you three trigonometric functions, it will be quite difficult to add this kind of periodic functions using trigonometry. Okay. Instead, if you use this phasor technique, then you can use the concept of vectors. The way we used to add vectors, the same way we can add these phasors. So let's see question number 4 now. Three simple harmonic motions of same angular frequency and equal amplitude A are superimposed on a particle. All are in same direction such that the phase of second motion is 60° ahead of the first and phase of third is 30° ahead of second. Find the resulting amplitude of the motion of the particle. So there are three simple harmonic motions. Each of them have same amplitude. So the length of each arrow will be same, but the phase of the second motion is 60° ahead of the first. So let us say the first simple harmonic motion is represented by this phasor. So this length is your amplitude, which is A. The other one is 60° ahead. So ahead means your angle should increase this way. Okay, so this is ahead. This is 60° ahead. This is also A. And the third one is 30° ahead of the second. So 30° ahead of the second means the third one is here. this is the third one, which is 30 degree ahead. 30 degree. Okay. So each one of them is A. So what would be the resultant amplitude now? So basically you just use vector algebra now. Just add them using vectors. But if you draw parallelogram here and then draw the resultant here, then again you have to find the angle which will bisect this will be 30 degree, and then you have to again know the angle between this one and the resultant of these two. So instead of that you can take components. Okay, so let us say this is x and this is y. So along x, what is the amplitude? This because of this phasor, the amplitude is A, because the whole vector or the whole phasor I should say is along x. Second one is 60 degree with x-axis, right? So the component of this A along this axis will be A cos 60 in the same direction. And this vector will have no component, so no need to include it in x component. So that will be, this is your A by 2. A plus A by 2 will be 3A by 2. Fine? Okay. Similarly, along y-axis, what will be the resultant amplitude? This A will have no component. This A makes 30 degree with y-axis, so it will be A cos 30. You can also write sin 60, okay? But this angle is 60. But then if you know this angle, then you can just use the adjacent component, which is cos 30. Plus, this is completely along y, so it will be A. So this will be A cos 30 is root 3 by 2 plus A. So that will be A 1 plus root 3 by 2. So once we know the x and the y component, the resultant amplitude will be how much? The resultant amplitude will be AR equals to, once you know x and y component, you can write root over AX square plus AY square. See, this is the beauty of using phasor technique. Whatever knowledge of vectors you have, you can directly apply here. So that will be root over this 3A by 2 square will be 9A square by 4 plus AY square. If you square this, you will get A square 1 plus root 3 by 2 square. 3 by 2 square. Okay. So you can simplify this. So here you can take A square common, then take root, so A will come out. So it will be root of 9 by 4 plus A plus B whole square formula you can apply. So it will be 1 plus root 3 by 2 square will be 3 by 4 plus 2 times 1 into root 3 by 2. Fine? Okay. So now you can just do the remaining part. This will be A root over. So this is 4. Till here I will do, okay, till here. So 4 is 9 plus 4 plus 3 plus this 2 and 2 will cancel, root 3 will be A will be 7, 7 plus 9, 16, 16 by 4 will be 4, so 4 plus root 3. So in such questions where the mathematics is, the arithmetic is not that simple, you have to keep checking with the option, okay. So this is option B, right. Let's see the next question now, question number 5. So question number 5 has to do with, again, friction concept should be remembered. So when a body is on top of another body and there is no slipping, then you know that if one body tends to move on top of the other body, and if there is still no relative movement, then the friction which acts is static friction, and static friction is self-adjust. Okay. And what is the maximum value of static friction? Maximum value of static friction is mu s into n. Mu s is the coefficient of static friction, and n is the normal force or normal reaction between the two surfaces which are in contact. Okay. So let us read. A block with mass m rests on a frictionless surface and is connected to a horizontal spring of force constant K. So there is a block of mass capital M. and the other end of the spring is attached to the wall as I have shown. A second block with mass small m, this small m, rests on top of the first block. The coefficient of static friction between the two blocks here is mu. Find the maximum amplitude of this oscillation such that the top block will not slip on the bottom block. This is smooth. Okay. So question is, what should be the maximum amplitude of this block so that this small block should not slip on this. Okay, so together they should oscillate. So if this is the small block and this my hand is the bigger block connected to the spring, as this oscillates, it should move together. Okay, if I do too fast, you can see it slips, right? So just try to understand. Okay, so as it oscillates, the first thing is you know that according to the question they should oscillate together. So what will be the angular frequency? Root over k by m, which m? The m which oscillates here, you want both of them to oscillate together, so mass will be m plus m. So that is the angular frequency, right? Okay. Now in SHM, they are asking find the maximum amplitude. So we need amplitude to come in the picture, right? So you know in SHM the acceleration is minus omega square displacement from mean position. So what would be the maximum acceleration? Minus omega square a. So this we know from SHM. Now, if they want to move together, they must have same acceleration at all moments. Otherwise, what will happen? This will have different acceleration, then this means what? This will have different displacement because displacement after time t is what? Half at square. If initial velocity I assume 0. So if acceleration is different, then at same time displacements will be different. So if displacements are different, it means if one goes 1 centimeter, other may go half centimeter. So there will be relative slipping, which they don't want. So both of them should have same acceleration. Now, who is providing this block that acceleration? Clearly the spring force. But what about this mass which is on top of this capital M? So if I see that mass, let me draw here. Okay, this is the surface of capital M. So for this block, who is providing this maximum acceleration? It cannot be the spring force because the spring is not in contact with the mass small m. So it must be who is in contact, capital M, and mg and normal force cannot provide horizontal acceleration because those forces are vertical. So that must be from friction. Okay. So if you had Newton's second law for the small block, it will be friction provides static friction because there is no slipping provides this acceleration ma, and you want friction to provide even the maximum acceleration, right? If friction cannot provide the maximum acceleration, how it will provide the other accelerations? So maximum acceleration, so that will be equal to minus m omega square a. Now you know that this friction has a limiting value, right? So whatever static friction is acting must be less than equal to maximum static friction. Where here? Okay. So friction is in magnitude. Okay. In magnitude, if you calculate, no need to worry about the minus sign. So in magnitude, the value of the friction should be less or equal to the maximum. So m omega square amplitude should be less or equal to maximum static friction. And that has a formula, right? It is mu into n. Where here? And that n has to balance the weight of this small m, that is mg. This capital N is nothing but mg. So your n gets cancelled, so your amplitude should be less than or equal to mu mg by omega square. So a should be less than equal to mu g divided by omega square. Now omega is this. So omega square, if you do k by m plus n, it will be k by m plus n will go up, n plus m. So a should be less than this, means this is what value? Maximum value, right? Because your if a number, let's say x should be less than 10, then 10 is the what value? Maximum value of x. So this is the maximum value of the amplitude which the question was asking. So which option it will be? Option B. So try to analyze this question properly. While doing later JEE advanced problem, we will include friction here also, and then we will see how the problem will change. So now the next question, question number 6. It is based on again all the questions are based on simple harmonic motion. So the chapter is oscillation, but here you have to remember about uh, when a body moves in a circular path with some uniform speed or angular speed, it requires what force towards the center? It requires a centripetal force towards the center, and some contact force or some other forces whichever can act on the body should supply that centripetal force. Okay. So here question number 6 says a small trolley of mass 2 kg resting on a horizontal frictionless turntable is connected by a light spring to the center of the table. So imagine this whole board to be horizontal. Okay, horizontal. So this is a turntable, this center, and there is a trolley which is connected to a spring. The relaxed length of the spring is 35 centimeters. So right now, imagine nothing is happening. It is resting on the horizontal table, and the length of this spring is 35 centimeters. When the turntable is rotated with some angular frequency, omega, which is given to be 10 radian per second, okay, in SI units they have given, the length of the spring becomes 40. Then they are asking what is the force constant of the spring. So the moment this starts rotating, if this also has to rotate, then it needs a force towards the center. But unless the spring stretches, there can't be a spring force which will provide the centripetal force. So it is obvious that as the turntable rotates and this block also wants to rotate with it, then it has to extend. And now the new length of the spring is 40 centimeters. So this is the extension of the spring X. It will be 5 centimeters, 0.05 meters. Right? Okay. So now that spring force, whatever spring force it will be, Kx, that must give you the centripetal acceleration, which is L omega square the radius. Now the radius will be what? Will it be 35 or 40? Once it rotates, it will reach this point, right? And then there it will rotate, right? So the radius will be your 40 centimeter. So let us say this 40 as R. Okay, so R. So what will be spring constant? So this X, let us keep in centimeter, okay? Because R is also in centimeters, so 5 centimeter. Mass of the trolley, how much it was mentioned? 2 kg. So mass of the trolley is 2 kg. Omega is 10, so it will be 100. And the radius is 40 centimeter. So sometimes there is no point converting everything into SI units. This centimeter and centimeter will cancel. This 5 8s will be 40, 8 2s will be 16, so 1600 Newton per meter. So actually you don't see any oscillation here. So basically in this scenario you have to just consider as this turntable rotates, this will be pushed out. If you start from rest and suddenly give this angular frequency, then it will not stop there, okay, actually it will oscillate. But we have assumed that it has reached some point and finally it has stopped and then it is revolving. So we have considered it to stop there, though actually because of its inertia it should continue further, right, and it will perform oscillation. And who will play the role of gravity in that case? The role of gravity will be played by this omega square r. So this will play the role of gravity. So this is like an mg. So time period, if they ask, will be 2 pi root over m by k. So anyways, here g doesn't come in the picture. Okay. So later on we'll see problems like this where there may be a pendulum in spaceships and all. So even without gravity, you can create pseudo gravity by making things rotate, right?